Let us look at another example of time value of money. You are thinking of buying a car and a local bank is willing to lend you $20,000 to buy the car. Under the terms of the loan, it will be fully amortized over 5 years, that is 60 months, and the nominal rate of interest will be 12% with interest paid monthly. What would be the monthly payment on the loan? What would be the effective interest rate on the loan? So let's first draw this example on a time scale. So here the tenure is 60 months. I'm taking it in months because the interest is being paid monthly. That means compounding is happening monthly. So N is 60. Now I nominal is 12%, but then since the period is month, we need to convert this 12% per annum into monthly interest. So this becomes 12 divided by 12, which is equal to 1%. So 1% per period. So now on the time scale, let's say this is 0, 1, 2, 3, 4, and so on, and this will be 59 and 60. So these are in months, and for each period the rate of interest is 1%. Now the amount of loan is $20,000, and we want to find out what will be the monthly payment. So this becomes a case of an ordinary annuity with, of course, multi-period compounding, because compounding is happening on a monthly basis. We know the present value of this annuity, so we'll use the present value formula. So let's first do the first method, which is to use the present value of an ordinary annuity formula. So we know the formula is PV is equal to A into 1 divided by I minus 1 divided by I into 1 plus I to the power n. Now present value is $20,000, so or 20,000 is equal to A is what we want to find out. A into 1 divided by I is 1%, and here we have to express this in 1 divided by 100. So 1 divided by 100 is 0.01 minus 1 divided by 0.01 into 1.01 to the power n. N is 60. So let's try to calculate this using a calculator. So 1.01 x to the power y 60 multiplied by 0.01 equals to, and this is 1 by x, and this is negative, so negate, and plus 0.01 1 by x, this is equal to 44.955. So or 20,000 is equal to A into 44.96, or A is equal to 20,000 divided by 44.96. So this is again 1 by x multiplied by 20,000. So this is $444.89. So this is the monthly payment that you will have to make if you take a loan of $20,000 to be paid in 5 years at 12% interest per annum. Now this is actually a typical case which happens in real life, because typically the banks and other financial institutions ask that the repayment of the loans should be done on a monthly basis. And in some cases, these monthly payments are also known as EMI. So if you know how much loan you want to take, if you know what is the percentage of interest that the banks are charging, then you can find out easily how much will you have to pay on a monthly basis to repay the loan. Let us look at another method of solving the same problem. The second method that we are going to look at is using the present value factor for an annuity, also known as PVFA. So basically what has been done is that in this formula, this portion has been standardized and the values of the combination of I and N have been used to create a table with the value of the entire calculation. So the table looks something like this. So you have periods 1, 2, 3, 4 and so on, and then you have rate of interest 1%, 2%, 3% and so on, and then plugging these values of these combinations, so 1% and 1 period, that is N is 1, the value of this is calculated and is given here, and so on. So our formula basically becomes PV is equal to A into PVFA for N equals to 60 and I equals to 1. N equals to 60 and I equals to 1%, of course. Therefore, now PV is equal to 20,000. So 20,000 is equal to A into, now the PVFA value for N is 60 and I is 1% is 44.955. So A is equal to 20,000 divided by 44.955. So this becomes 20,000 divided by 44.955. So this is equal to 444.89. This is the same answer that we got in the previous method. Now let us look at another method, which is to use the financial calculator. Now in order to use the financial calculator, basically there are 5 key buttons that we have to take care of. First is N, which is the number of periods, which in this case is 5 years or 60 months. Then next is I, which is 12% per year. Present value is 20,000. Now this I'm keeping positive because this is the amount that we are getting from the bank. Payment amount or the monthly installment is unknown, and future value is 0. The future value is 0 because all the loan amount will be paid using the equated monthly installments. So there is no need for any future value to be found out. Now let's see how to use the financial calculator to solve this. Now here the compounding is happening on a monthly basis. So we have to be careful when we enter these values. So let's see how we enter the value for NI and PV, and of course FV is 0. So for N, first we'll enter 5. Now this is on a yearly basis. However, the compounding is happening on a monthly basis. So we have to convert this into monthly period basis. So we'll click G and then we click this 12x. So that means there are 60 periods. Next we have to enter I. So first we'll enter the yearly interest rate, and then we'll click on G and then 12 divided. So that means this is the monthly interest rate. Next we'll enter the present value. So 20,000 is the present value. 0 is the future value, and then we have to find out the payment amount. So the payment amount comes out to be minus 444.89. Minus indicates that this is an amount going out of our pocket. So because we received 20,000 as loan, we have to pay back an amount of $444.89 per month to the bank. So using all the three methods, we pretty much got the same answer. So we got the answer for the first part of the question, which is what would be the monthly payment on the loan. Now the second part is what would be the effective interest rate on the loan. So let's try to find this out. So as we have already figured out, the compounding is happening on a monthly basis. The nominal interest rate is given to us as 12%, and the monthly interest is 1%. Now to find the effective interest rate, basically we have to use the formula 1 plus I to the power n minus 1, where n is the number of compounding periods and I is the rate of interest per compounding period. So this is equal to 1 plus I is 1%, so 0.01. Now what is the value of n? So here we are trying to find out that if the annual interest rate is 12% and if this is being compounded monthly, then what is the effective annual interest rate? So here n will be 12 minus 1 because there are 12 months in a year. So this becomes 1.01 to the power 12 minus 1. So 1.01 x to the power y 12 minus 1. So this is equal to 0.1268, or basically 12.68%. So this is the effective interest rate per annum.